3, I put B, the P with a little caret over it.
I got just the P.
Yeah, I got C.
How did you get just the P? Let me look where I looked. Oh, right there. The sample proportion P with a caret is 1 point of the number line that estimates the true value of the true proportion P.
Mm.
So I was looking at 2.1, the second paragraph. So did I just understand it wrong? The reason the study was conducted. True population proportion. Okay. So number 4, the requirements for constructing a confidence interval are satisfied, true or false. Don't we need to know the z-score in order to do the confidence interval?
We just need N and P.
The z-score is going to be the confidence level. Oh, so for question 4, we're just plugging that into the n times the p with the caret and seeing if that's greater than 10, and then we're going to do it again with the parentheses 1 minus p with the caret and see if that's greater than or equal to 10.
Okay, so we have 25 and 75. But I guess I was confused because that's what I did for number 5. Was
Yeah, aren't they the same thing?
No. So question 4, that's the one where, like I just said, that we do.
Mm-hmm.
Question 5 is we're testing to see if it's a normal distribution, which it is because the sample's over 100 or over 30.
Okay, I just thought it said in the notes that in order to find the confidence interval and for a hypothesis test, I thought it said you use those same tests.
So,
like in 2.
order to use the hypothesis test, or no, sorry, let me rephrase this. The confidence interval needs to be satisfied in order for the central limit theorem to be applied. Did that make sense?
Okay. But is there anything else that... Because I feel like you do the same thing to get both of those answers. Like, it's just the getting the confidence level, and then because that's yes, then the hypothesis test is also yes.
I guess the best way to explain it is like, imagine n was 25, but then p was like 75% or something, or whatever. Just like, and let's pretend that the confidence interval was satisfied because the sample size is 25. The hypothesis test would not be satisfied because we can't apply the central limit theorem, or we don't have enough data to tell us that the data is normally distributed.
So you would kind of use the same thing, but it would also have to be a big enough sample, as well as for the confidence interval to be satisfied, right? For the hypothesis test. Because I mean, you would need the confidence interval to be satisfied as well as have a a big enough sample size.
Yeah, I guess the best way to say this is like you can have, if you have a successful confidence interval, then you can have a successful hypothesis test, but you can't have a successful hypothesis test if you have an unsuccessful confidence interval.
Okay, that makes sense.
Right, 6. And P, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state. Did you guys put 0.75?
Yes, I put 0.750.
Do I need the 0 at the end? Because it says decimal points.
Sorry, question 6.
Yeah.
Yeah, I got 0.75.
0.75? No.
Mm-hmm.
But the 0 can go or cannot go, right? Like, it doesn't matter.
Yeah, you don't have to put the 0 at the end.
All right. Wait, guys. Sorry. Number 5. What did you guys put? 0, 5.
True.
True.
Mm-hmm.
Poor true. Cool. I just wanted to make sure because I always get these quizzes wrong now.
Determine margin of error for the 95% confidence interval. So the same, the old margin of error, the 1.96 times standard deviation divided by the square root of n.
Yeah.
So 1.96. What's the number?
No. It's going to be
0.109.
It's the
No, I didn't do it.
z-score times the square root of 45 over 60 times 1 minus 45 over 60 divided by 60. End parentheses.
Oh, wait, what?
Where did you get the
Is that 3 equals
It's in the
step 4?
oh, it's in step 2. Or let's see, the margin of error. Margin of error is just the z-score times.
Oh, I see it down in
the
so
p
n
times 1
equals
minus p over n.
c divided by m squared. P, is this all one thing?
It's
P?
It's the equation for the standard deviation. That's what it is. For this proportion. Yeah.
Okay, so n equals 1.96 divided by m. What is m in this situation? Where did my note go?
Mm.
Is m my mean? So it's 6. And that's square rooted. And then p. But what's our p?
Oh, number 3. It's in lesson part 3. It's like it's the first equation under sample size calculations.
Yeah, I just saw it. Okay.
And so, yeah, it's all it is it's just the z-score times the standard deviation of p of the with the caret. That's all it really is.
Mm.
Okay, so Josh, so I'm just to make sure I'm calculating this right. I have 1.96 divided by 60, and those are in parentheses squared. And then is my p the 0.75 because we found that in answer 6?
Wait. Did you say 1.96 divided by 60?
Yeah.
No, it's going to be 1.96 times the square root, open parentheses, 45 divided by 60. And then that's going to be in one set of parentheses. And you're going to open a second set of parentheses. It's 1 minus. Oh, it's just.
Will you screen share yours?
Yeah.
I feel like going in circles and not accomplishing what I need to on this one.
I think I've got the answer, but I'm not sure if I'm right.
Okay, so the margin of error is going to be equal to the z-score, which is, in this case, 1.96. And then that's going to be times the square root. Oh, that was, why did I do that? Why did I think that was a good idea?
We understand.
It's because I just finished putting the equation into Excel. So that's why. Okay, it's going to be the z-score times the square root of 45, which is x, over 60, which is n, right? And that's going to be in one set of parentheses. And then the next set of parentheses can be 1 minus 45 over 60. And that's going to be in a set of parentheses when you put it in the calculation. And so make sure you close that second parenthesis, that second set of parentheses, and then that's going to be all over 60. So when you put it into a calculator or into Excel, it should look something like parentheses 1.96 parentheses. Or I guess I don't need that. I don't need that first parentheses. So 1.96 times. Let's see. Square root parentheses. That's going to be 2. I might have to add 1. Yeah, it's going to be 3 open parentheses, and then it's going to be 45 divided by 60.
This is why I get things wrong in calculators.
Right. Open parentheses 1 minus parentheses 45 divided by 60. 60. And then there's going to be closed, and you're going to close that. So, yeah, it should look like that. And then that will close the entire top of the equation. Then you divide by 60, and then you close that.
Oh my goodness.
No, and then there's one more close. So it should look like that. Is what the equation should look like.
Oh.
Let's see if I mark this in red. So those are matched. those
Did
are
you
matched.
get 0.1096?
That's matched. That's matched. Oh, no, I was right. Never mind. I don't need this last one.
Yeah, did you get 0 or 0.0141?
No, I didn't.
I got 0.033.
Wait, what did you get, Josh?
So I got 0.10956731.
Oh, I got almost the same as you, but I got 0.1096.
Yeah, that's right. That's what I got.
Nope.
I did that twice. I got it on
Zero.
calculator and in
Oh
Excel.
my! Oh my gosh! Yeah, I rounded it up and I didn't even notice it. Oh my god!
0.09,
Oh,
but if that rounded, then it'd be 0.11.
Here, let me show you what it looks like for me in Excel. Okay.
That gave me a syntax error.
It's it's super complicated. Okay, where's my mouse at? Okay. So if you look at where it's at, what I put into Excel for the margin of error, I added this to this area just because I like it. So I have here C17, which is going to be the Z-score, which I had to put in manually. I had to type that in manually. And then it's going to be times, I wish I could zoom in. Oh, wait, okay. It's going to be, times the square root of, and then there's going to be, I got 3 parentheses, and then all of this nonsense. So it's kind of a ridiculous.
wow, that's more confusing. I'm not gonna.
Where did you get that Excel sheet? Is that something that we got
Yeah, we got in the lesson.
in the lesson?
I just didn't calculate.
Yeah, if you like, the lesson literally says. Let me see if I can find it.
It says use Excel. I saw it somewhere.
It does, but I don't know if it's so really good.
For confidence intervals for one proportion, using only a calculator is tedious. An Excel spreadsheet has been created to help quickly and accurately perform these calculations.
You just, if you do it in color, you just have to break it down and it'll take like a long time to look at it.
Yeah. Well, the only thing is because I put it into Excel first, and then I was worried that I got the equation wrong. And then I went and did it on my calculator, and I was like, "Oh, it's right, cool."
And
So-
also, I found it. I found a calculator at my house, the TI-84.
Nice.
Yeah. Saved my life. I don't have to do it on my phone.
And the nice thing about this is because it does tell me my confidence interval, I can just see that if I subtract by 0.11, basically, that it matches my. I don't know what p hat's supposed to stand for, but if I subtract the p hat minus the confidence interval, then I get the margin of error.
So for number 7, are you gonna just put 0.109?
Yeah.
Or are you gonna add the 6?
No, because they're asking to go to 3 decimals.
Oh, true. I didn't see that.
But why wouldn't you round and just do 0.110?
Oh, that's right.
Well, because we don't need the 0.
So are we gonna put 0.100? Wait, I'm confused.
7 is that 0.109, right?
Yeah,
Yeah.
but there's the 5 on the end, so I rounded it up to 0.11.
So 0.11.
Yeah, that's what I'm
Oh.
gonna put. I'm just gonna put.
0.1. Okay.
Okay. Mhm.
And put the lower bound. Okay, where's the formula to calculate that? I don't have it in Excel like you do.
Yeah, because it's that Excel. Um, um, I clicked on the lesson and went to Excel spreadsheets zip. I think that's what it was. And it's the third one. Or,
It's called
no.
categorical data analysis.
Yeah, that's the one.
You found that one on the lesson?
Yeah.
There it is.
Mm.
What did that do?
So the lower bound is
The P, because that's the lower bound. So we have the P minus Z score, square root of P with a caret, 1 minus P with a caret. That's 10. And then our upper bound is P plus Z, square root P with a caret, 1 minus P with a caret, divided by N. So what is our P with a caret? $45. Are we still using 0.10 for these ones? No, because that's for only the 2 questions. One, two. Okay, so you're doing 0.75 minus, are we still doing 95%? So 1.9 square root of 0.75, 1 minus 0.75 divided by N. Is our N C the sample size? Did you get 0.640?
Yes.
So upper bound would be 0.859. So did you write 0.86?
Mm-hmm.
For the upper bound?
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? I would expect it to get bigger, but
I put A.
Yeah, I put decrease.
Yep.
It said it in a lesson somewhere.
I just hurried and typed it into my calculator and deleted 60 and put 80. It decreased. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals a half. What is the smallest N and B? And both requirements will be met. I was confused by this one at the last test we took. So I'm not sure.
Mhm.
Question 11.
Yes.
Yeah.
So all you're going to be doing, because the equation is going to be the n times p is greater than or equal to 10, or the n, just do 10 times 0.2 or 0.5. No, 10 divided by 0.5. And then see if the number that you get can be used for both equations.
Yeah. 10 divided by 0.5.
Yeah.
5. So for the other one, the 5 times 1 minus 0.5 is 2.5, which is less than 10. So that's not going to work.
Wait, what?
You said to have a number. So 5, for example, because if we have 10 and then we take it in half, which would be 5, then we see if that will work in the other equation.
No. You want to, because the equation is n times p equals or is greater than or equal to 10. We know that p is going to be 0.5. So
it has to at
if
least be
you
20.
do 10 divided by 0.5, you'll get 20. And then see if 20 times 1 minus 0.5 works.
Yeah, and it's equal to 10.
10.
Yeah. So we know that 20 is the smallest that it can go.
Okay, that makes sense. I don't think I got that last time.
I didn't understand that.
I don't think I did either.
The smallest.
Not sure if I still understand that by myself. How would
Oh, wait.
times?
Maybe 20.
Okay.
Um,
Let me. I'll share my. screen. So the equation for the confidence interval stuff is p is greater than or equal to 10. And then the other one is going to be n times 1 minus p is greater than or equal to 10. So if we know that p is going to be p is equal to 0.5 because it's 1/2, then the first one we're going to want to do is going to be n times 0.5 is greater than or equal to 10. So we divide by 0.5. So n is going to equal or greater than or equal to 10 divided by 0.5, which we find out is n is greater than or equal to 20. So if we plug that 20 into n over on this equation, that's not a divide, that's just a separation. We should get, it should be 20 parentheses 1 minus 0.5 is greater than or equal to 10, right? So we know that 20, 1 minus 0.5 is going to be 0.5, which is going to be the same equation as the top one in this case, in this scenario only that I've seen. 20 times 0.5 is going to be 10. So 10 is greater than or equal to 10. So thankfully, we have another equation that we can practice that with on this next one.
Yay.
So for this one,
I hate these.
let's do it. P is equal to 0.01. Is that right? No. 0.1.
0.
Just 0.1. 0.1. Ugh. So if we plug that in to here, greater than or equal to 10, divide by 0.1, n is greater than or equal to 100. Right? My n's look like h's. So if we do 100 parentheses 1 minus 0.1 greater than or equal to 10.
100
times 0.9 10, and you'll get
90.
Right? And so the reason why we know that 100 is the lowest that you can go is because anything less than 100 will be less than 10. And we figured that out from the first equation. And so by doing the first equation, we've already solved half of it. We already know that the number that we get from the first equation is the lowest possible one we can get, because that's the equal to. Everything else is going to be greater than. And so when we plug that into the second equation, if that's greater than 10, then it works.
Hi.
You need to get in the bath tonight. When I'm done with my quiz, I'll get you in the bath.
Day one. You're not really.
Unless Lander wants to drive. Lander wants to take the bath down for your sisters. just gonna help you get in the bathroom, and you and Emma can play, and then I'm gonna be down here. All right, for the water quality study, about 60% of the macroinvertebrate, where's that? Water quality indicators have historically been associated with good health. The researchers suspect that water quality in areas decreased. They conduct this test using a significance level 0.05 with the following hypothesis. P is equal to 0.6. P is less than 0.6. They collect new data, and this time N80 and X indicate good health. The conditions for conducting a hypothesis test satisfied. N and P. So the N would be 80, 0.6. 0.6 is 48. And what is it? 80 times 1 minus 0.6 equals 32. So I would say true because they're both over 10. Did I do that right?
Yes.
Okay, what is P? X divided by N is P. So 38 divided by 80. Sorry, sometimes I have to talk out loud. Nobody else
It
said
helps.
it's 10 to 5. So I got 0.475.
Yes, I got that too.
Yeah, me too.
Find test statistic.
And then for 15, I got a negative
number. I don't have the equation for that one written down. Okay, I don't have the formula for the test statistic.
It's the z-score.
Isn't that in step 4? The z-score, the value minus the mean?
Yes, it's step 4 of 4.1.
Oh, the big one. P minus P divided by square root of P minus 1 point P. 1 point P.
This is the one that you put in the applet, right?
Mm-hmm.
Oh.
Joshua, did you get an answer for this one?
For 15?
Yeah.
Yes, I did.
Did you get negative 2.282?
Yes,
I
I
just
did.
don't know if I did it right.
Yep, that's what I got.
Okay. Finally, because in the homework quiz, I didn't get this one right. Gotta figure it out.
Right, come on, come on. Oh no! Negative 10. Okay, I typed in 0.475 minus 0.6 divided by the square root of 0.6 parentheses 1 minus 0.6 parentheses divided by 80. Did I type something in wrong? Because I didn't get the same answer you did. Oh, wait. That number, that's the Z. Let's see. That's the Z-score. Well, but that would be the test statistic. Okay, Josh, look at mine. I'm going to screen share with you. If I can flip you around. Flip. Okay.
Okay, so
What did I do wrong?
you need to put a parentheses around the 0.75 and the 0.6.
These. Parentheses.
Yeah, I don't like it.
That.
Okay, and then there needs to be, yep,
Negative 2.28.
What application is that, Michelle?
On mine is on www.cymath.com, cymath.com. Sometimes it works better than my calculator on my phone. I'm able to get it to look like I want it to, like on my paper. And if I do it on my phone, then I have to do it in sections.
that's pretty cool. Wish I had thought of that.
I don't have a regular calculator, so.
I have a regular calculator and I can't do it.
There's one thing that calculus taught me. It's to just throw out parentheses. You can always delete them later.
It always gets me confused, but that's always my problem. I never put it in enough parentheses.
Yeah. So when it comes to really big problems like this, I've gotten to the habit of just throwing out 3 of them. I always start an equation with 3 parentheses, especially like these really big ones, because it seems like it's the magic number.
That's ridiculous.
Yeah, it really is.
That I missed that whole problem because I missed those being in parentheses.
Mm-hmm.
Okay, so what is the p-value?
So what you're going to want to do for this one is, because the alternate hypothesis is less than 0.6.
Where's my applet?
Yep, you go into the applet,
Where?
shade everything to the left, type in the z-score, and you'll get the answer.
Okay, so we have negative 2 point, what was it? 2.28. So everything to the left. So 0.011.
Yep.
And then 17, I put reject the null hypothesis.
And that's because 0.011 is less than 0.05.
Reject. Which of the following best summarizes the conclusion of this test? There's insufficient evidence to conclude. Okay, I'm gonna really process these because these mess me up every time.
I know, me too.
No.
I believe in you.
Do ya? Because seriously, I'm not confident in a single thing I do in this class. Like every answer I get, I'm like, wait, did you guys get that? Like nothing. Unless you guys say, yep, I got that too, then I'm not confident.
Wait, 13, you guys put true, right?
Remind me what 13 says.
13?
Mm-hmm.
Oh. I put true. The conditions for conducting a hypothesis test are satisfied.
Oh, yes. Yeah.
Okay. So there is sufficient evidence to conclude that the water quality in the area has not decreased.
So I know it's sufficient.
It's sufficient.
Because it is sufficient because we rejected the null.
Mm-hmm.
So sufficient. So is there sufficient evidence to conclude the water is not decreased?
Well, what's the alternate hypothesis?
Is less than 0.6. So it wants to know if it's...
Which means that would mean that it's decreased. The alternate hypothesis is looking for if the water is decreased, right?
Right.
And the null hypothesis means that there's no change, right?
Right.
So if we reject the null and we have sufficient evidence that we can reject the null, then what is the only other option? I guess it's
Oh, because we're okay. So it's the other sufficient then
yes.
that it
So
has decreased.
right.
Oh, okay.
D.
Yes.
Yeah,
See, if only I could
Yay.
show you what goes on in my head.
That would be cool. If you could figure that out, that would be great. Because we don't see things the same at all.
Basically, every time one of those questions is asked, it's asking for, is there enough evidence, or is there not enough evidence, or is there enough evidence to prove the alternate hypothesis? That's all that question's asking. And so the end of that question is always going to be the alternate hypothesis, right? So if, like, let's say we're talking about the water, and it's saying that the alternate hypothesis is that the water has decreased, then all we're looking for when we do the equation is if there's enough evidence to support a decrease in water. And then if you reject the null hypothesis, that means you have enough evidence. If the p-value is less than the level of significance, then you have enough evidence to support the alternate hypothesis. If you don't, if you fail to reject the null hypothesis, then that means you don't have enough evidence to support the alternate hypothesis.
Right.
So,
Okay.
yeah, that's how those questions work. It's definitely feels a lot more complicated than they actually are, but I think it just takes a little bit of time getting used to the wording and everything.
It's easy to confuse yourself when you look at the wording.
Right.
Mm-hmm.
For sure.
All right, I'm going to go get my babies that are prunes out of the bathtub. Mom of the year. And I'll talk to you guys later.
Alrighty. I will
All right.
talk to you later.
Thanks.
Yeah, we can just
yeah.
What? Of when we're meeting or
No,
the final project thing.
That thing.
Oh.
Yeah.
I sat and saying it was on the 18th. Thanks, bud.
It's already getting very.
I think we have to submit the entire thing by the 18th, as in like our whole design plan and stuff. So we should at least consider what we're going to talk about.
Yeah.
Well, because part of it's due tomorrow, though. Like, because we have to turn it in pieces.
Yes. So what would be interesting to do a study on?
Mm.
What about hand washing in public bathrooms?
Gross. I don't want to sit in a public bathroom and record data.
Of course you want to sit in the public bathroom.
So do we have to ask people?